Next up, meet Dr. William Hirzy, an EPA scientist, Senior Vice President of the union that represents all the scientists, toxicologists, lawyers, engineers at EPA headquarters in Washington, D.C. He's testifying before the Senate Subcommittee on Wildlife, Fisheries, and Drinking Water. Dr. Hirzy and 10 other unions, a total of 11 unions representing more than 7,000 employees at Washington, D.C. EPA headquarters, called for an immediate moratorium on drinking water fluoridation based upon the proven link between fluoride and bone cancer in young males. Listen to Bill Hirzy. Interesting testimony.
Putting this stuff into drinking water is, in essence, just a hazardous waste management tool. It has nothing to do with dental health whatsoever. It has to do with defending the reputations of people who have been promoting fluoridation for years and years and years and now find themselves way out on a limb and have nothing more to say except safe and effective, safe and effective, safe and effective, when in fact it's neither safe nor effective, but they can't change. They're riding a tiger and can't get off. Somewhere between 200 and 500,000 tons of scrubber liquor from the phosphate fertilizer industry is now being managed by putting it into your drinking water system. There's got to be a better way to do it, to manage that stuff.
Good morning, Chairman Smith and Chairman Crapo and fellow staff workers. Thank you for the opportunity to appear today to present the views of the union on the issue of fluoridation of public water supplies. Our union represents the staff, scientists, lawyers, and others who analyze hazard, exposure, and economic data and advise management how to use them in public health protection. I'm not here today to speak for EPA, but rather the union, founded 17 years ago to protect EPA workers from unethical pressure by EPA managers. It was on that basis in 1985 that we first got involved in this issue. In 1997, we voted to oppose fluoridation, and our opposition has grown stronger as more adverse data on the practice has come in. In the interest of time, let me state our recommendations first. We ask that you order an independent review of the cancer bioassay of sodium fluoride mandated in 1977 by Congress. Evidence for carcinogenicity in that assay was systematically downgraded by a special executive branch commission appointed and run by the very agencies that Congress did not trust to run the bioassay in the first place. That action saved fluoridation temporarily. We ask that you order chronic toxicity studies on the two waste products that are now used in 90% of fluoridation programs. EPA says there are at present no chronic toxicity data on them, and we ask that you order EPA set an MCL for fluoride that's truly protective of all American citizens, infants and adults alike, because the current one does not, in violation of the Safe Drinking Water Act. We ask that you order epidemiology studies using dental fluorosis as an index of exposure to determine the extent of other toxic effects, especially effects on the brain and bone in the population that are attributable to fluoride. We ask that you convene a joint congressional committee to give this issue the full airing that it deserves. It's been 23 years since the last one, and it's high time for a new one. I offer the following in support of these recommendations. The American people, and especially our children, are getting way too much fluoride. 2/3 of children living in fluoridated communities have dental fluorosis in at least one tooth. Dental fluorosis is the visible manifestation of toxic overexposure to fluoride during their developmental years. The initial findings of the cancer bioassay were for clear evidence of carcinogenicity, and that is consistent with several epidemiology and many mutagenesis studies. The protected pollutant status that fluoride enjoys within EPA and other federal establishments is remarkable, as the charts over here show. EPA stated regarding the chemical used in 90% of fluoridated communities that, quote, by recovering fluosilicic acid from fertilizer manufacturing, water and air pollution are minimized, and water authorities have a low cost of fluoride. In other words, EPA's solution to pollution by this waste product is dilution, as long as it's not dumped into rivers and lakes, but rather directly into drinking water systems. Congressman Calvert of the House Science Committee has letters of inquiry out to EPA and other federal entities on this subject. The 1983 report of a Surgeon General's panel on fluoride to EPA was altered without consultation or notification of the panel members. so as to help EPA justify an outrageous set of drinking water standards promulgated in 1986. The results of a 50-year experiment conducted in Kingston and Newburgh, New York, show that there's no overall difference in dental caries rates between the two communities, but there's a significantly higher incidence of dental fluorosis in the fluoridated community. Since 1994, there have been 6 studies that show adverse effects of fluoride on the brain, even at the so-called optimum level of 1 part per million. The epidemiology studies that we recommend above should make a prime effort to look at brain effects, given the national concern over attention deficit and hyperactivity disorder and autism in our children. 3 trial judges since 1978 made findings of fact that water fluoridation poses an unreasonable risk to the American people. Fluoridation proponents like to say that there's no real controversy about fluoridation, and they're right. When these 3 disinterested trial judges heard weeks of testimony, they came to the same conclusion that our union did about the unreasonable risks involved. The findings of fact remain untouched in those trials today. Recent publications indicate a link between the use of silicofluorides for fluoridation and elevated blood lead levels in children and antisocial behavior. And leading dental researchers are changing their views on the safety and efficacy of fluoridation. Doctors John Calhoun and Hardy Lineback, both former spokespersons for fluoridation, have published recantations of their former position. On behalf of EPA's professional community, I urge the subcommittee to convene a select committee for a national review of water fluoridation. It's high time we do that, and I'd be happy to take questions. Thank you.
Mr. Hirzy, I know you're an employee of the EPA, and I'm assuming that your views conflict with the agency on the issue of fluoridization. Is that correct?
Given the fact that EPA has set the maximum contaminant level as indicated on the chart at 4,000 parts per billion, and the so-called optimum level is 1,000 parts per billion, one could assume that. A citizen inquired of Congressman Bob Young to ask EPA about the American Dental Association listing EPA as an endorser of fluoridation. The then Assistant Administrator for Water, Bob Perciasepi, wrote back to Congressman Young and said that EPA had asked ADA to take EPA's name off the lists of endorsers of fluoridation. So it's a wash. EPA, I think, is playing the good federal soldier in supporting this program that's been a federal mandate more or less for 50 years, but officially it's not on the list of endorsers.
You cited several studies which were very interesting. I saw them in your statement. What kind of are these basically independent studies with no peer review, or has there been sufficient peer review to give these studies more credibility or not?
Now, the ones that are of most concern to us are the peer-reviewed studies that have appeared in neurotoxicology and teratology and brain research in 1995 through 1998. The work of Phyllis Mullinex, for instance, indicated that when rats were dosed, pregnant dams were dosed with fluoride, that would result in serum levels in the brain of the pregnant dams that mimic serum levels in human beings drinking water at that maximum contaminant level. The dams gave birth to pups that were hyperactive, born hyperactive, and remained hyperactive throughout their life. That was the reference in my testimony to asking for a epidemiology study that looked after that particular endpoint. Also in that same journal in 1998, a group of Chinese workers published the results of some research in which they gave basically the same doses that the Mullinex group did, and indicated that there was a depletion of certain critical chemicals in the brain, basically lipids that constitute the neuronal membrane, that could explain on a mechanistic basis the outcome of the Mullinex study. Then in brain research in 1998, a group of researchers, which included an EPA scientist, found that at 1 part per million, sodium fluoride resulted in changes in the cerebrovasculature in the test animals and also kidney damage.
Mr. Olson, do you share the concerns expressed by Dr. Hirzy on fluoride?
Well, I don't consider myself an expert on fluoride, but we certainly think that First of all, you should know that we sued over the original fluoride standard over 10 years ago, urging that the standard be dropped. We thought a standard of more in the neighborhood of 1 or below was more appropriate because EPA admits that there are dental fluoroses, spots that occur on children's teeth when you get up to the 4 part per million level. And there is a lot of science, as Dr. Hirzy suggests, that's come out since then. So I guess our view is that certainly there is definitely a need for a careful peer review of all these new data, and there are significant concerns that have been raised over the last 5 years from some of the studies. We don't have a position right now on what the standard should be, but we think that a careful peer review and an open process to look at that new science is definitely called for.
Groups of 50 animals, rats and mice, were dosed either with fluoride in their drinking water, either at 0, 11, 45, or 79 parts per million fluoride over their entire lives. And then they were studied during the course of this exposure. Normally that is essentially a two-year period. And then the animals were autopsied, those that survived, and their health status was tabulated, including tumors and so forth. The tumor incidence that was originally reported would have supported a finding of clear evidence of carcinogenicity for sodium fluoride based on all of these tumors that I mentioned.
Well, the studies that were done show that there was an increased level of bone cancer and other kinds of cancer in the animals. And I got a hold of the contractor report and reviewed it very carefully. And not only was it reporting cancers in the animals, osteosarcomas, which bothered me a lot because I've been trying to produce osteosarcomas in animals for almost 20 years. And the only luck I ever had was with a experiment in dogs and monkeys, and the osteosarcomas took nearly the lifetime of the animals, and we were using radium, which specifically produces that in bones. And here we have a compound commonly available that did it in rats in 2 years or less. That was upsetting to begin with.
Well, there were tumors in the oral cavities of the test animals. There was osteosarcoma, the bone cancer in male rats. There was also an incidence, a relatively high incidence of rare liver tumors in mice, not the normal kind of liver tumor that is seen, but this is a hepatocholangiosarcoma.
In that same study, there were cancers of the liver that are very rare, according to the board-certified veterinary pathologist at the contractor in Patel. And those really were very upsetting because they were hepatocholangiocarcinoma, a very rare liver cancer. And when that occurred, something similar that occurred in vinyl chloride at a far less well-conducted study, it was determined that it was carcinogenic, highly carcinogenic.
There's also some osteosarcoma, not of the bone, but found in soft tissue, which is a rarity. Taking all of those tumors into account, it would have led to a finding of clear evidence of carcinogenicity. However, a commission was appointed by the Department of Health and Human Services that came down to rescue fluoridation from such adverse findings.
Well, I went to a meeting that was held in Research Triangle Park in April of 1990, the latter part of April, in which the National Toxicology Program was presenting their review of the study. And that I went with several colleagues of mine, one of whom was a board-certified veterinary pathologist who had originally reported hepatocholangiocarcinoma as a separate entity in rats and mice. And I asked him if he would have an opportunity to look at the slides and see if that really was a tumor or the pathologist at Patel had made an error. And he told me after looking at the slides that, in fact, it was correct. And at the meeting, every one of the cancers that was reported by the contractor had been downgraded by the National Toxicology Program. Now, I've been in the toxicology business looking at studies of this nature for nearly 25 years, and I've never seen that. Never ever seen where every single endpoint that was a cancer endpoint had been downgraded. I'd seen one or two endpoints argued over, usually on a definition of what is a cancer in that particular tissue, but I've never seen every one of them downgraded. I found that very suspicious, and I went to see an investigator in the Congress. at the suggestion of my friend Bob Carton. And this gentleman and his staff investigated very thoroughly and found out that the scientists at the National Toxicology Program down at Research Triangle Park had been coerced to change their findings.
The American Dental Association claimed that the rats were fed levels of sodium fluoride which humans don't receive in their diet, 75 parts per million or 45 parts per million, and so the results were irrelevant to humans because the doses were so high. How would you respond to that point?
Well, it's common practice in cancer bioassays in order to limit the number of animals that are used to give doses that are generally always in excess of what humans get. It's a matter of statistics, basically. The level of regulatory concern at EPA generally is one person in 1 million, 1 person in 100,000, 1 person in 10,000, 1 person in 1,000 developing cancer from a particular exposure. Given the kinds of exposures to a chemical that humans might get. Now, in order to mimic that exactly in an animal population, you'd have to study 1 million animals, or 100,000 animals, or 10,000 animals, or 1,000 animals, and this begins to get completely unreasonable in terms of use of animals, cost, and the like. So what we do is rather to limit the number of animals but increase the dose so that one could plot from a 0 exposure in the control group to the maximum tolerated dose, and then plot the response based on these different doses. And one normally gets some sort of a dose-response curve if the material is carcinogenic. And that's what was seen in the case of sodium fluoride. The highest dose level, by the way, 79 parts per million, is relatively low compared to the doses that are given to animals in other corresponding bioassays. It is not at all unusual in a cancer bioassay for animals to get 1,000 or 10,000 times the dose that humans get. In this bioassay, the level of 79 parts per million of fluoride was only literally 79 times greater than the so-called optimum level. It's only about 20 times higher than what the level that EPA says is okay to have in your drinking water. That's a remarkably close level to have the highest dose level in an animal study, and to have a positive response for cancer in the anticipated target organ, namely the bone. It's a remarkable finding.
So have other chemicals been defined as carcinogenic based on studies like this?
Oh yes, any number of substances have been classified as carcinogens. Formaldehyde, butadiene, styrene, and any number of chemicals that I could tick off. But and the dose levels are much higher compared to what the human exposures are, as opposed to the situation here. This is only 20, the animals got overt, frank bone tumors, bone cancer, malignant cancer of the bone at a level only 20 times higher than EPA says it's safe to drink. That is a remarkable narrow margin of safety.
I felt at the time that the report was very, very interesting. It showed that the levels of fluoride that could cause the cancers in the animals were actually lower than those levels we've seen in people who are ingesting lower amounts but for longer periods of time. And that was very, very worrisome. It meant that the general population could be exposed to fluoride known to cause cancer in animals and have higher levels in the spot that cancers were being produced in the bones.
Benzene, which is a known human carcinogen, when they studied in animals, the animals get 10 to 100 times more benzene stored in their bones than do humans. And here we have the reverse situation where we've got animals with less fluoride in their bones than humans, and the animals are responding with osteosarcomas.
If these tumors found in the rats weren't downgraded by the National Toxicology Program, what would have been the ramifications for fluoridation?
It would have been over. It would have required EPA to set a maximum contaminant level goal of 0. So the MCLG for carcinogens is 0. If it's 0, that means you can't add any of this stuff to any water supply, and that's the end of fluoridation. there's other evidence for carcinogenicity besides this bioassay. There's a substantial body of mutagenesis studies, that is, studies in which a chemical's ability to cause changes in DNA have been proven. Also, fluoride is known to be an enzyme poison in any number of enzyme systems, and repair of damaged DNA by enzymes is an important anti-cancer mechanism that the body has. And if some of these repair enzymes are inhibited by fluoride, that could indicate fluoride's ability to work as what we call a promoter as opposed to a primary carcinogen. Carcinogenesis is a very interesting and complex subject. There are so-called complete carcinogens, chemicals that in fact damage the DNA and then allow an aberrant cell to reproduce wildly and develop a malignant tumor. There are other substances which are called promoters, which do things like inhibit repair enzymes. And once a cancer, an incipient cancer forms, if these repair enzymes are not able to go in, sense the aberrant cell or aberrant strands of DNA and either repair the DNA or kill the cell, then the tumor is allowed to grow. Those are classified as promoters. It may well be that fluoride works in both ways, as a primary carcinogen and as a promoter. The question of risk of acquiring cancer is a very complicated one, and you really can't say that if you live in an area with 4 ppm fluoride in the bone, 2% or 3% of the population are going to get bone cancer, because that's not the way things work. But they are definitely at elevated risk.
If we were to remove fluoride from the water and stop fluoridation, wouldn't there be a significant increase in dental decay? Because often dentists will say that the communities which are unfluoridated have a 50% increase in 50% more dental decay.
Well, that's an interesting and I think unsupported statement. Europe, which is only about 2% fluoridated, has essentially the same dental caries rates as the United States does. The results of the 50-year experiment in Kingston and Newburgh, New York, show that overall there's no difference in dental caries rates between the fluoridated community and the unfluoridated community. There's not a dime's worth of difference. Actually, the unfluoridated community has slightly better dental caries data than does the fluoridated community. Likewise, the massive study that was done in 1985 and 86 by dentists trained by the National Institute of Dental Research, surveying tens of thousands of American children, basically found that there was no statistically significant difference in what's called the decayed, missing, and filled teeth index of measuring dental caries rates. And also, when one looks at the communities that were studied in that exercise, those that are fluoridated versus those that are non-fluoridated, and one aligns them with best performance to worst performance, it's a complete shotgun scatter point. There are non-fluoridated communities that have very good performance. There are fluoridated communities which have poor performance, and it's all mixed up in that arrangement of communities in terms of their dental caries rate. So there's really no correlation. And when one again refers to leading dental researchers such as Dr. John Cahoon or Dr. Hardy Lineback, who have been in this game for a long time and looked at it very critically, and you get them, former proponents of fluoridation, saying ingesting this stuff doesn't work, that if there's any benefit, it's from brushing your teeth with fluoridated toothpaste.
And during that time, I reviewed the literature as well and discovered that there really wasn't any evidence that fluoride swallowing does any good. In other words, systemic fluoride has very little to do with protecting teeth.
Now, how many dental researchers around the world agree with you that the benefits of fluoride come from applying the fluoride directly to the tooth rather than through the whole body.
I would say the majority of dental researchers who are knowledgeable about fluoride, karyology, the mechanisms of how fluoride prevents dental decay, the majority would agree that it's a topical effect.
It all adds up very clearly in my mind to putting this stuff in the drinking water is, in essence, just a hazardous waste management tool. It has nothing to do with dental health whatsoever. It has to do with defending the reputations of people who have been promoting fluoridation for years and years and years and now find themselves way out on a limb and have nothing more to say except safe and effective, safe and effective, safe and effective, when in fact it's neither safe nor effective, but they can't change. They're riding a tiger and can't get off.
Do you think it's safe to say then that part of the reason why these tumors found in the rats were downgraded was because of the reputation at stake for the Public Health Service, the U.S. Public Health Service?
Without a doubt.
That they didn't, that because they've advocated fluoridation for over 50 years, that they didn't want to have to admit now that perhaps fluoride caused cancer.
I think it's a very good assumption. I think so, yeah. If people want to ingest fluoride, they can ingest fluoride by other mechanisms. If they want to use fluoride in an effective way, they can go buy fluoride toothpaste. But to be taking this known toxicant into your body for no benefit makes no sense at all. You're using your body basically as a sink for a hazardous waste of the fertilizer industry. And if you feel comfortable about that, God bless you.
So are you saying the fluoride that we put in the water is a waste product of an industry?
Yeah, 90% of the fluoride that's used in drinking water systems comes from the scrubbers of superphosphate fertilizer manufacturing plants.
So the first fertilizer industry can't emit the fluoride into the air because it's a pollutant.
That's right. And we have a letter from the Deputy Assistant Administrator, Rebecca Hanmer, Deputy Assistant Administrator for Water back in the early 80s, saying essentially that EPA views the recovery of hydrofluosilicic acid as an ideal solution to a long-standing problem, that by recovering this stuff, air and water pollution are minimized and water utilities have a low cost of fluoride for fluoridation. And when you read between those lines, and it doesn't take a fine magnifying glass to read between them, what she's saying is if this stuff gets out into the air, it's a pollutant. If it gets into the river, it's a pollutant. If it gets into the lake, it's a pollutant. But if it goes right straight into your drinking water system, it's not a pollutant. It's somewhere between 200 and 500,000 tons of scrubber liquor from the phosphate fertilizer industry is now being managed by putting it into your drinking water system. There's got to be a better way to do it, to manage that stuff.